Z-score formula. This is not a very hard formula. It is one that we are going to formally learn, I think it's chapter 2, and then we're going to use it the entire year. It sets the foundation for kind of the crux of how statistics works. Because as a general theme, we're not going to dive into it specifically. We're just going to practice the algebra with this. But as a general theme for statistics, I want you to think about it this way. How far away is our observation from what we expect? And is it far enough to be surprised? That is essentially what statistics is saying. So I'll give you an example. If I took a coin and went to flip it heads and tails, I don't think any of you would question the fairness of this coin if I got 6 heads and 4 tails, right? We know that it's reasonable that we might not get exactly 5 and 5. So then the question is, at what point should we then be surprised? At what point should we question whether or not this coin is fair? And to answer that question, along with some other tools and resources, we will end up using a z-score. Now, a z-score is based off of a formula that looks like this. And it doesn't mean a whole lot right now, and that's okay. I'm going to unpack what these terms are so you know their correct names, and then we're just going to practice the algebra right now. We're not going to understand what it's saying, how we would find it. It's just going to be plug in and find one of the missing variables. Obviously, Z stands for z-score. We'll unpack that a little bit more. X is going to refer to a data point. So it is going to be any individual data point from our set of observations. X is always used to refer to just the individual data points. X bar, not a very creative name, I know, right? It is literally called X bar. X bar is shorthand for mean. This is our traditional mean in the sense of add up all the numbers, divide by how many numbers there were. Anytime you see X bar, that is describing the mean of that data. And then finally, this little guy down here, that is a lowercase sigma. You are probably more familiar with the uppercase sigma, which you used in summation notation last year in Integrated 3. And this lowercase sigma is a symbol we use for standard deviation. Again, we haven't unpacked standard deviation. You don't need to know at all what it is. All I will say right now is it is a way to measure the spread of the data, just like how we had the range in the previous video. So it is another type of calculation we can use, and it has places where it's used instead of the range, and that'll get unpacked during the school year. All I want you to take note of right now is we have the following names: Z, X, X bar, and sigma. And all you're going to encounter in this particular set of practice is you're going to encounter problems where they give you 3 of these values and ask you to find the missing one. So for example, if I set up the following problem and I gave you this, okay, we would be going on a little journey to solve for the number 5. And just to showcase how this would go about, I will remind you that anytime you've got a fraction right here, you can get rid of the fraction by multiplying by that denominator on top of the fraction. But again, whatever you do to one side, you have to do to the other and cancel that on out. So the 10 on top and on bottom cancel out right there. The 10 times 5 would give me 50 is equal to x minus 8. In which case, this wouldn't be too hard to figure out because you add 8 to the other side. And your final answer is going to be x is equal to 58. So you'll have some problems like that where you are solving for an x. To move some things around, hey, you could have a problem where instead of solving for x, you are solving for sigma. And so let's just make up some numbers right here, and we'll go 12 minus 7 over sigma. Okay, so same idea. You can use some different strategies from an algebraic standpoint. Obviously, 12 minus 7 is 5, so we can clean that up a little bit. And then at this point, you might be able to just kind of think about, well, if I want this to be a 4, I don't quite know what that is. You might use a cross-multiplying strategy, right? 1 times 5 must be equal to 4 times sigma, in which case you would have 5 is equal to 4 sigma. Divide both sides by 4, and so sigma is equal to 5/4, or 1.25. Okay? And then this just keeps playing around. I'm not going to go through a ton of examples right now because I think you are capable of practicing them on your own. But obviously, if you run into issues, I'd be more than happy to do some additional examples.